afternoon. How are y'all? Good. Welcome to the Houston Security Conference. My name is Terry Galoina, and I'm a volunteer here. And I would like to introduce Tom Houpt. And the topic, which you can see here, is Rising Above the Noise, Smarter App and API Security and ADR. So Tom comes from all the way to Texas from North Carolina. I guess we could have a debate on who has the stronger accent. I think I probably do. Anyway, Tom is a cybersecurity professional with over 6 years of experience in sales, channel account management, and solutions engineering. Formerly at Carbon Black, managing channel and direct sales, and later supporting strategic alliances at a partner solutions as a partner solutions engineer. Most recently, he was a senior channel engineer at Point Wild, formerly Pango, which enables global partners to integrate security SDKs and accelerate go-to-market. He specializes in technical sales support, partner onboarding, and bridging business needs and technical execution. So with that, if y'all could help me welcome Tom.
Yeah, let's see.
Okay.
Perfect.
Good. Thanks.
All right, good afternoon, everyone. First off, is this a good volume? I'm not like yelling at you guys right now, right? Thank you, appreciate it. I've been accused of yelling too loudly before. So I'm Tom Houpt, I'm with Contrast Security. We're gonna be talking over some of the problems with AppSec that we see at this day and age, and then what we see in terms of what the future of AppSec looks like, how we can fix those problems that we've had, and how we can learn from mistakes that we've made in the past to make a better future. So jumping into it, a quick agenda here, setting the stage. We'll look at some third-party reports. I do come from a vendor, so obviously I'm gonna have a little bit of Kool-Aid in all of this, but that's why I'm bringing in the third-party report, so try to keep myself as unbiased as possible. We're gonna spend a lot of time talking about the challenges that face AppSec security. That's redundant, but and why now is the time for ADR. What it means, what it's going to do differently for you and your AppSec programs, and then we'll look at the future state and wrap it up with some takeaways. So let's just start by setting the stage here for application security. It consistently, in my point of view, gets pushed to the back burner. It's intrinsically tricky. Right, when you look at something like network security or you look at something like endpoint security, this is something that's been around for a while and yes, has had its trial and tribulations, but generally speaking, it's a little bit easier to get your hands around it from a security perspective, right? When you need to push out an antivirus agent, for example, you've got your users, you've got your sales, you've got legal, you've got HR, and generally speaking, they're all gonna get just about the same image. And so you just push the AV agent out with whatever tool that is, sits there and does what it's supposed to do, right? It's not to say that there aren't intricacies involved with endpoint security as well, but you can get your hands around it. But when we get to AppSec specifically, it becomes a particularly tricky environment to manage. You've got developers who are creating web apps and are constantly getting pushed at this day and age to produce more code faster and faster. And of course now AI, it's 2025, it's all over the place. People are using that to write code, and obviously it's not always the best code that it produces, and it comes with plenty of vulnerabilities and issues that come along with it. So what you get with developers as security sees them is this unique group within your organization. They have this product that they're creating, the web apps and other development that they're creating, and it's not as, call it static as say an endpoint, which I realized is a gross overgeneralization, but it's really hard for security to get your hands around that. It's constantly being updated, it's constantly being changed. Security doesn't necessarily want to own AppSec, and developers don't necessarily want to own AppSec. So a lot of times, it doesn't get solved for, right? So that's what we're trying to fix. But let's drill down into some of these numbers here, and this is where I'm talking about for the third-party reports. I'm going to throw a bunch of numbers at you right now. So looking at the Verizon DBIR report, we can see from this graph that since 2022, exploitation of vulnerability has been going up as a #1 initial attack vector, right? Phishing is still prevalent. Credential abuse is still prevalent. Those are just as important, but we can see clearly that exploitation of vulnerabilities within our applications are on the rise. And my guess, this trend will continue in 2026 as well. Then when we look at Mandiant, you can see the dark blue is 2022, light blue is 2023, and black is 2024. So exploits were the most frequently observed initial attack vector, and that's the 5th consecutive year that they've seen that. And then when we look at the CrowdStrike State of AppSec Security Report, we've got facts and figures here, but I like this point that they make at the top. The custom applications are complex and constantly changing, right? There's new features being pushed out all the time. That's what development a lot of time is measured on. How many new features can you get out, and can you do it in a quicker amount of time? AppSec isn't necessarily something that they get measured on. Yes, there might be incentive, or yes, they might be told that they need to make sure that they're coding with security in mind or something like that. But generally speaking, it's let's get new features shipped faster, and then we'll probably worry about security after that. So one more slide. Oh, okay, hold on. One more slide of, there we go, of stats for you. If there's a picture that you want to take, this would probably be a good one to take here. So let's break these columns down individually. So prioritization problem. And this is what 61% of AppSec professionals cite as their top challenge. So with SaaS tools, with DAS tools, static application security testing, dynamic application security testing, they create a lot of noise, right? I've been talking with a lot of folks out on the floor over the last day and a half, and what happens is you send off your SaaS to do a scan, and you get back hundreds, you get back thousands, depending on the app or the apps, you get back tens of thousands of alerts. Most of them are false positives. And that's just human behavior, what happens next, in that if a developer is tasked with sorting through a list of 10,000 results to try to find a true positive, they're just not going to do it, right? If someone gave me a list of 10,000 things to search through, find the one true positive, maybe if that was my only job, sure. But of course, they're again not necessarily measured or tasked with going through and finding that. So it becomes a lot of noise, and that's 1 week. Then the scan happens again the next week, and they're just looking through all of this noise. And ultimately what happens is that vulnerability doesn't get fixed, or vulnerabilities don't get fixed. Now, when we're looking at SaaS tools, when a vulnerability is identified, it takes the better part of a year for it to actually get fixed. So 290 days for one vulnerability to be fixed. And of all of the apps that organizations may be running, that could be one vulnerability within one app, and they could have 15 different apps out there, right? So there's vulnerabilities galore that just aren't getting fixed and aren't getting solved with SaaS tools. And then this one was the most shocking to me as I read through these 3 reports. So these 3 facts up here come from the Verizon Data Breach, the Mandiant, and the CrowdStrike report. 54% of major code changes only 54% of major code changes undergo a full security review before deploying to production. Only 54% of code is reviewed before it's pushed to production. We've been shifting left for a decade, and we're getting just over 50%, at least getting a SaaS scan to it, which again has its own problems. So that's a lot of code that's in production that we don't know if it's got a vulnerability in it or not, right? And certainly that's a problem. Now, when we look at the human side of things, that was weird, of AppSec, we've siloed teams, right? I've talked about this a little bit already. There's AppSec that doesn't necessarily want to own development and or app security. They might be tasked with it, but it could be a bottom priority for them. You've got developers who, again, don't necessarily want to own the security aspect of their development. And then you've got other tools that are, or other departments that have a hand in it, like GRC, IT may jump in there, and others, right? So we've got these teams tasked with different things that, and again, none of them really want to own AppSec, so it becomes hard. And then we take this reactive approach. Yes, there's the SaaS tool, which does something. That's better than nothing, maybe. But generally, we wait until something goes wrong till we really address an underlying problem. Prime example, Log4j. People started paying attention to AppSec once that popped off. There's tool overload as well. So we've talked SAST, we've talked DAST, there's other ones out there as well. You're trying to put this all into your CI/CD pipeline, and you're getting feeds from all of these different tools that you have. And it doesn't necessarily all come together the way that you need it to create a healthy AppSec program. And then there's the exploitable versus theoretical. So you could have an old monolithic application that has a library in there that is 3 or 4 versions or longer out of date, right? So that is certainly a vulnerability and one that we should work to fix. But if that library is not called, if it's just kind of still hanging out in the code, but it's not actually utilized anymore, then it's more of a theoretical risk. There is a scenario where it could be exploited, absolutely, but in a day and age where we need to prioritize and work with dev and sec to prioritize the risk of applications, the risk of vulnerabilities, we should be focusing on what's exploitable within an application. And then, of course, this is not necessarily unique to AppSec itself, but there's the compliance focus only. So if you check all the compliance boxes, then you're safe, right? Obviously, that's not true. Those are guidelines, and frankly, in my opinion, the bottom tier standard to achieve, and then we need to make sure that we're surpassing that standard. And then finally, I've talked about this already, the difficulty managing the backlog, right? Huge numbers that we're getting from SAST and DAST tools. There may be a vulnerability in there. More often than not, it's just noise. And then when we look at the tooling side of AppSec, we have fragmented tools. I've talked about this. We've had analyzing pieces that we're getting from SAST, from DAST, maybe from our WAF, right? And trying to piece it all together ourselves. We've got false positives and false negatives out the wazoo, and we're getting a lack of context. We run a SAS scan, and it says, hey, you got a vulnerability with this library. Great. Where's that library in my millions of lines of code, right? So even if we know that this library is susceptible, now you got to scroll and scroll and scroll until you find where it is, and then you can start trying to figure out what's going wrong with that library or other vulnerability. We've got unrealistic test environments as well. So we're trying here, and it makes sense to do this, to put it into QA after it's in development. We'll run tests at it, but that's not necessarily what the app will be exposed to in production. So it doesn't necessarily give you the real feedback that you need from real users in production to make the app right. And then when we're looking at the current state of AppSec, we're using a point-in-time approach that is just looking at whether a vulnerability exists or not. We're not doing any sort of behavioral analysis for the attacks coming into the applications themselves and blocking against the exploitation of those vulnerabilities. And what we see is, of all of the vulnerabilities that a SaaS tool will pick up on, only 5% of those are truly exploitable. So we're getting 95% of the results is just true noise. So now we have ADR. This is what we're bringing to market as contrast. And we've seen this in other parts of the stack as well. We have CDR for cloud, we have endpoint detection and response, identity, threat detection and response, NDR, et cetera, right? So it only makes sense that we take the idea of detection and response, which is behavioral oriented, and bring it to the application layer. And it also makes sense that this was the last place to sort of adopt this, right? Because again, security for AppSec just becomes this part that's really hard to wrap your hands around. So we've seen great success with this on the endpoint, right? I spent 6 years working at an NGAV and EDR vendor, and it was exactly what our customers needed there. And it makes sense on all of these other parts of the stack, and so therefore it also makes sense within the application side. Understanding the behaviors that our app is doing and the behaviors of attacks that are thrown at our apps to block and alert accordingly. Now, I bring this slide up not to say that EDR is a bad thing. Again, I just said I worked at a vendor for 6 years. I think EDR is a phenomenal thing. But EDR, when it comes to application security, is not sufficient. So EDRs are going to miss high-impact attacks like SQL injection and untrusted deserialization, right? It just doesn't have visibility. It's sitting there at the OS level, understanding what's happening within your operating systems, but not necessarily understanding exactly what's going into a field on the front end of a web app, right? When we look at all of those attack vectors on the left, from path traversal to command injection to untrusted deserialization, we can see these other EDR vendors are able to pick up on bits and pieces of it here and there. But ADR, because it sits within the application itself, has a true understanding of all of these attacks as it's coming in real time. And then we have WAF. And again, this is not to say that your organization does not need a WAF. This is not to say that we're looking to replace WAFs. WAFs are great when it comes to things like DDoS attacks, right? But they require a lot of TLC at the same time. There's a lot of effort that individuals or teams need to put into configuring the WAF itself to make sure that it's blocking the right amount of traffic and the right type of traffic. But generally what we see is it's either over-blocking or it's under-blocking. So again, with the idea of this whole presentation being rising above the noise, let's look at what's actually happening within the application. Let's have our WAF focus on network-oriented attacks, and let's leave the AppSec itself to the application layer. So this is an example from one of our customers. This was one app over 1 month, the amount of noise that was coming in. So 426 million calls to potentially dangerous functions. When we talk about noise, 426 million is a pretty dang big number. And again, this is one app over 1 month. So multiply this by 12 months and multiply this by all the other apps that they may have in their environment, and that number gets exponentially larger. We can bring it down to 365,000 security relevant observations. That's WAF-oriented. Non-viable attacks are probes. So they tried to exploit something, but they weren't able to, and 45 viable attacks. So even 45 of itself, of those 426 million, that'd be great if we could get it down to there. That's cutting through the noise in and of itself. But with ADR, we're going even farther than that. We're bringing it down to a total of 10 for this app over 1 month versus 426 million that started. So we're looking at 5 custom code vulnerabilities, 3 CVEs, and 2 incidents that popped up from this. So the answers are in production. We talked about the problem with SAST and the problem with DAST. It's a lot of noise, looking at things like all of these repos and libraries, but just doing a quick scan over it to see whether it exists or not, and see what version of a library there is. But not even necessarily understanding things like a custom function for a SQL query, right? So it doesn't have an understanding of that. It just knows that that exists. No real understanding of the behavior or the intent of the behavior behind that. We have simulated environments. We don't have real users testing this in real time. Point-in-time testing. So if you run a scan at 10 p.m. on Tuesday, then you get the results a couple hours later. That doesn't provide any real-time protection for you. You just have a point-in-time understanding of a whole bunch of false positives and a couple of true positives in there. And there's weak code coverage. That one might be a little debatable in my opinion. I didn't necessarily create this, but they told me to use this slide. And then no threat intelligence. So it's just a scan. Yes, maybe some of them are getting farther along than the last time I've seen a SaaS tool where they're able to implement a third-party tool in there to better understand one of the libraries or something like that. But it doesn't understand things like we do in production, where there's fully assembled apps and APIs. There's real users filling out fields, clicking on buttons, doing different functions within the front end of the web app that touch the back end. These are real environments that they're working in, right? It's up and running, it's in production, so we can see the real code behavior. So that same function that handles an SQL injection, if that wasn't exercised in testing, then it would very well get exercised while it's in production. So then we could see the way that SQL queries are handled by that function. Is it handled in a safe manner, or is it just passed through and right back to the database? And then, of course, real attackers and exploits. So by being able to pick up on all of this information in production, we're able to create a graph. We're able to understand the architecture on a micro level of your applications themselves. We're able to understand where the API calls are being made, what's being sent to a database on the back end. We get an understanding of probes that come in, attacks that weren't able to successfully exploit a vulnerability, risky functions, again with that SQL injection. Maybe this isn't handled in the right way. This isn't written in the right way from a safety and security standpoint. So a lot of what we get when we're at these booths or when we're talking with customers is they're worried about testing in production. And I understand that, right? It's a different idea. We've been shifting left for 10 plus years now, right? But that hasn't solved the problem. We're still getting, as we saw from those reports at the beginning of the presentation, we're still getting hit all the time. And the exploitation of vulnerabilities within apps themselves are growing. So we need to take a different approach. I think shift left made a lot of sense at the time. It was an easy way to start with AppSec, but we need to evolve past that. And so if you're afraid to test in production, just remember that your customers are always testing in production. Users, once this app is up and running, users are clicking all over the place and testing out the different functions, libraries, et cetera, within an app. So when we look at fixing some of these problems, right, we're talking about AppSec and developers coming together, bridging that gap, right? A pretty common term in security when you're at a conference like this. But what we've done with ADR is taken the information that we can grab from the code base itself, and we'll present it to developers in a way that makes sense for them. Because we're in the app itself, we're able to understand when a vulnerability is truly exploitable. We're able to show them exactly what line of code that exploitation is on. And we're able to, because it's 2025, we've put AI into our tool. We're able to create a pull request with AI. The AI will write a piece of code to fix that vulnerability. The developer goes in, checks out that vulnerability's newly written code, and decide whether or not they want to merge it, right? So we've made it easy for them. But then AppSec, again, is interested in the attacks coming against our web applications themselves. So they're able to see when there was a SQL query coming its way, or a SQL injection coming their way. We're able to see when there's unsafe deserialization, when there's path transversal. Because we take a behavioral-based approach to this and not a signature-based approach like what's happened in the past, we're able to stop the exploitation of new 0 days. So Log4j, I threw that out earlier in this conversation, something had everyone worried there for a while. Our customers were protected for 2 years prior to that Log4j exploitation coming out. So where are we headed? Well, we have AI-driven security. I just talked about that. We're not going to be fully AI, right? Because no one's going to trust AI that much. But we do want to make the everyday workflow of developers and security a lot easier by implementing AI. So we're looking at not only that smart fix functionality that'll rewrite a vulnerable piece of code for you. We have that in there already. We have an MCP server, and we're still figuring out new use cases for that. So with the APIs, right, we're able to look at, say your web app's got 45 APIs or API routes. If during testing you've only exercised 40 of them, you probably want those other 5 tested before moving on down. So you can have the MCP server, you can have the MCP server exercise those 5 routes that haven't been hit, right? You could have the MCP server in the IDE itself, so a developer, when they reach a certain milestone, is able to ask the MCP server, is there vulnerabilities in here before it even gets into production? And then there's plenty of more use cases for that MCP server and for making sure that the detection, prioritization, and developer support is better than it is already. Now, we've talked shift left. I think the way that we really want to start looking at it in 2025 is observe right and shift everywhere. Shifting left had its place, but we need to expand that scope. We need to expand that common colloquialism that we use right now because it hasn't been effective. SAST hasn't really worked. It was the right idea at the time, but we've got to evolve. So automation across the SDLC with runtime context. So runtime context is going to provide you with a better understanding of what users are actually using, what vulnerabilities actually exist within libraries, which what can be improved from the actual user data that we're getting from runtime context, right? So what's reachable versus what's theoretical. And then integrating security seamlessly into the developer and security workflows. That's important. We want to make sure, again, that we're closing that gap between developers and security as best that we can. And then again, risk-aware prioritization, so the theoretical versus truly exploitable. We want to make sure that we're prioritizing what's exploitable and cut through the noise to act with confidence. So as we get towards the end of this, we want to change the way that we measure app success. We're not just talking about making sure that we have a SaaS scan every Tuesday. We want to make sure that we focus on the reachability. In a time where AppSec's, where security lists prioritization as the number one cause of frustration when it comes to working with developers, making sure that we're focused on what's truly exploitable is the first priority there. And then, as security can do, they can sometimes come across as a police force. So you want to make sure that you're partnering with developers. You want to make sure that you're coming to them as equals and making sure you understand what they are measured on, what they need to do to make sure that they're successful in their job, and then the way that security can work with them to both have a successful outcome rather than just putting a blocker in the way and saying, hey, don't push this out until we make sure that this vulnerability has been fixed or something of the sort. I want to make sure that we integrate security into the workflow, so we have tests along the way throughout the SDLC. Again, with the MPC server, for example, being able to test those APIs, or being able to stop at a point in time and ask the MCP server, is there any critical vulnerabilities that exist in the code that I've already written? We want to be bold and try new things. Again, testing or running a software in production as your main AppSec tool is certainly something that can be scary to organizations who are used to that truly shift left idea. So by putting it in production, it is being bold, it is trying new things, but we need to try new things because, again, the old stuff hasn't quite worked for us yet. And with that comes the evolve from the shift left, right? So it's been good, it was a good place to go, but we need to make sure that we evolve that and improve on it. And then finally, AppSec, just like every other part of security, it's not a destination, but so much as a journey. So make sure that you're measuring progress. How many false positives are you getting 1 week over the next? How many vulnerabilities are you able to fix this week versus what you've done a month ago? Things like that. So I'll finish it off there. I do appreciate everyone coming today. I know it's been a long day and a half with a lot of these presentations and a lot of conversations. I appreciate you all coming down here. We have time for any Q&A that you may have. So if you have any questions, we've got, I believe, another microphone, and I'd love to.
So if y'all have questions, if you'll raise your hand, I'll run the microphone to you.
And if you don't feel like asking here, that's totally fine. We've got a booth as soon as you come into the convention hall.
So thanks for the presentation. Sorry I'm late, and I'm curious to know for the EDR, right? Where does that fit in if you have AppSec monitoring tools like, say, Dynatrace and Datadog? Is it going to provide the same functionalities, or how is that going to, and how does that integrate within your application stack, right? Because those monitoring tools, normally, some of them use agents, right, that you install. So for something like an EDR that you're proposing, right, how does that fit in, right? And do we get rid of the monitoring tools, or do they work hand in hand? That's my first question. My second question is, I know you mentioned we need to shift away from the principle of shift left, right, and focus on production. But if you're getting hit in production and is as a result of a weakness in your code, right, don't you think at that part it's still gonna cost significant time for you to fix that code issue? Because that's the overall principle of shifting left, right? So we can discover things very early on in the SDLC process, right, and remediate those. So if we want to focus on production, right, with something like the EDR, and we are getting hit by customers or threat actor at that level, right, and we discover it's because of a bug in our code, is that not going to cost us significant time for the developers to fix that issue?
Yeah, so let me tackle that second question first. So just to make sure I understand you correctly, if there is an issue right? And we're not taking that shift left or solely that shift left approach anymore. By not doing that, aren't we extending the time until it's fixed? Is that the right way of looking at that? Yeah. Yeah, so it's a good point you bring up, right? So within the ADR tool itself, there's interactive application security testing, right? So as a user interacts with code, then we're gonna understand what libraries it's touching or what function that it's touching, right? So we get an understanding, that same understanding that we would have if we did a true shift left idea. But then what we're also able to do is, because we have behavioral-based prevention in that tool, we're able to stop attackers from being able to exploit that vulnerability. We're able to stop them from actually, so it may be an unsafe parameter that handles the SQL query, right? So if we see that and we understand the behavior of what that function is supposed to do, we'll stop that. We'll throw up a 404 error, and yes, that'll be a problem within the web page itself. But when we're looking at which type of problem, I'd rather a 404 error and for a temporary amount of time a customer not be able to use that query than have it be a full database dump from an attacker, right? But then we also, we're giving developers time. So as they, as we make sure that we prevent any sort of exploitation of that vulnerability, they're able to take that, they still have that information, they have an exact understanding of what function is being affected, they have an exact understanding of what line of code that function exists on, so they're not scrolling through all of it. They can go in there, they can fix it, they can put it into a pull request and merge it. So the scanning approach, it may just see that as a perfectly fine function because it's not looking at the behavior of what that function is supposed to do. It may not understand that it's an unsafe parameter that's handling the SQL query. Does that answer your question? Okay. The other one you asked is how do we work with Datadog Dynatrace? Yeah, so they'll deploy in a similar manner. They'll deploy through instrumentation into the web app itself, and we do the same thing. We have, for the bigger vendors out there, for Datadog and Dynatrace, we have rule sets within our agents to make sure we don't interfere with what they're doing and to make sure that they, as best we can, that they don't interfere with what we're doing.
Yeah, you didn't talk at all about how this works, so I'm kind of curious if you could talk a little bit more. I don't know if you've got a slide on that or something, but like, how does this work exactly, and how do you know if behavior is bad or good, or if a particular behavior is somebody trying to infiltrate or exploit anything, and how do you know, like, in addition to the 10 things you found, if there weren't another 10 things you guys just did, you guys just missed?
Yeah, so from an architectural standpoint, we instrument directly into the web app, right? So we have sensors throughout the source code, and from that, we're able to understand, again, what libraries are in there, what functions are in there, but because we can follow the function, and we'll just stick with the SQL query, for example, because we can see, you know, is this just taking the pure SQL query itself and plugging it right into the database, or is it going to be parameterized and put in there? So if it's not parameterized and it's just plugged directly into that SQL query itself, then that's an unsafe way to handle an SQL query. So we're able to see if it does get safely handled before it's put into that query and handled to the database, then we're able to safely say that this is a safe way to handle it versus an unsafe way to handle it. So that's going to be true across deserialization libraries. That'll be true across someone trying to do something else that I can't think of on the spot. In terms of the efficacy, I would point you towards third-party reports that we have of that, right? So again, I'm work here, I've got a certain Kool-Aid, but we have third-party reports that can talk to the efficacy of our solution, which I'm happy to send over to you as well.
So when you say you're instrumented throughout the source code, does the developer have work to do, or you automatically put everything in the source code, or what kind of work is involved in doing that instrumentation?
Yeah, that's a good question. So I'm sorry, did I cut you off? I didn't mean to cut you off. So if we take like a Python web app, for example, you just pip it in. It's a pretty simple way to just get it out there. The agent will essentially deploy itself once you've called it, and it goes in and puts itself in various parts throughout there. So once we're in there, there may be some work from the developer to shift some of their code around to handle it, but generally speaking, that's one of the areas we've put a lot.
What about like a big complex C# app or JavaScript or Node.js, and it's a big app? I mean, how much work is involved in in
Yeah,
that?
it's a good question. So that's where we've put a lot of time and effort with our deployment to make sure that we don't put a lot onto the developers. That's been one of the main focus areas for our development team, is to handle it and make it as automated as possible. So once it's in there, and it will deploy itself once it's called in, it will, your development team, your sec team is probably going to want to do some testing to make sure that it is in there the right way. If there's any issues with it, that's what our professional services team is able to handle. I'm not going to say we're going to be perfect every single time, right? But from what we've seen from our customers and from the POVs that we've done, it's a very straightforward process.
As an example, let's say you had a team of like 10 developers that have got some application they've been working on for like 3 years,
Yep.
and then they want to instrument for this. Is the onboarding time like a day, a sprint to 2 weeks? Is it a month? What does it usually take to?
Yeah, so there's two parts to that. There's the actual implementation of the agent itself, which is straightforward, and we're looking at like 20 minutes at most for that. But then there's the handling the human aspect of it. Making sure we can get everyone on a call at the same time with our PS to walk through to make sure it was deployed in the correct manner or adjust accordingly. So in a perfect world, we're talking 20 minutes or less. But realistically, in terms of working with everyone's calendar and everything, we're talking a week. Does that make sense?
Not really.
Okay.
But I can talk to you about other people that may have questions or whatever. We
Okay.
can talk to you about later. Okay.
Thinking about this with separate security and development teams in an organization, how do you see a security team essentially selling a development team on using a solution like this? Or
Yeah, so I think first and foremost, it comes down to it gives them more context and less false positives. This is assuming they're coming from a shift left shop where they've been riddled with false positives. So it's time saving on top of time saving, or sorry, it's pure time saving from that respect. Now you might need to sell them again a bit on the idea of running in production instead of just the shift left, and that is one part of it, right? If an organization isn't willing to leave shift left as the last part, we can still work with a SaaS tool. We can ingest that. It's a bring your own SaaS tool, BYO SaaS essentially. So depending on which one of that, we could ingest those results. But in terms of saying to a developer, hey, you don't need to search through all of these false positives anymore. We're going to give you highly accurate results. You know exactly what line of code to look for an issue. The time saving itself, I think, makes a lot of sense.
And do you see a lot of resistance from those teams in wanting to embed this in their code?
It depends on, it depends. So generally, I'd say it's about 50-50. Some people get this ideology and are on board with it right off the bat, and other people, they're comfortable with what they've done, and they will need to go through a POV to see what the impact of this tool can actually be. Yeah, you're welcome.
Other questions? Okay. So with that, let's thank Tom and appreciate you being here and the message you shared.